Kiddies, 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 welcome. Section 7.3 here. Hopefully you have your workbooks out and following along. We're going to cover some stuff that we talked about in 7.1 and 2. In 7.3 we're going to start to kind of put some things together from those two sections, and we're going to look at what are called shapes of distribution. So we're now going to look at data and see what it looks like as a whole. So let's jump right into it. Alright, so these are some things from section 7.1 and 7.2. 7.1 we focused on measures of center. So we talked about things like mean, median, mode, standard deviation, range, kind of that intro stuff, all the vocabulary. One of the main ones we focused on, again, was the mean, which was looking at the average of all the values. So again, why is this a measure of centers? Because if you think of the average, it should be found about in the center of all of your data values, especially if things are kind of even. If we don't have any what are called outliers, your mean should be somewhere in the middle of the data. And then we focused on another one called the standard deviation. Okay, standard deviation again was how far your data varies from the mean. So let's say we had a mean of that was equal to 8 and our standard deviation was 2. That means the majority of our data would vary from 6 to 10. Okay, 6 being 2 below 8 and 10 being 2 above 8. So those again are looking at things of center, and standard deviation talks about how much it's going to vary. In section 7.2 we started looking at distribution. That's taking a look at how data is spread out. So what we focused on, what were called box and whisker plots. Again, we had our box and our two whiskers. Okay, and remember there was 5 points of data that we looked at. We looked at the median, I'll just label with an M. We had our low value and our high value, and then we had our quartiles. So we had Q1 and Q3. And one thing we talked about was kind of the shape of these box and whisker plots and how it related to the data. You could have a box and whisker plot that was maybe more spread out to one side and a little bit closer together on the other. You know, it could be the opposite of what I just drew, closer together on the left, more spread out on the right. So that's where we started getting into shapes, where data is more spread out versus data that's close together. Again, reasons why we might see data being more spread out here, whoopsie daisies, more spread out on this side or this side is because of things like outliers. All right, and that's kind of what we're going to focus on today, but we're going to now visualize it in a different way. Okay, the way in which we're going to look at things is through what's called a histogram, or a bar graph, you might think of it that way. Again, what we're going to do is we're going to take a look at the data, and we're going to look at what's called a frequency table. We'll introduce that in just the next example. What it's going to do is going to give us, again, a sense, just like a box and whisker plot, about how the data is spread out. And you're going to see one of 3 things. Okay, the data is either going to be skewed left, symmetric, or skewed right. Now, what do each of these mean? Now, just taking a look at the picture, this one is skewed left. The reason why it's called skewed left, and if you look at it, it's a little backwards of what you might think, but a majority of the data, as we can see here, the majority of the data is on the right side of this graph, and it's skewed left because there's going to be some sort of value out here. It could be an outlier, for example, whatever it may be, but there's going to be some values to the left that kind of pull the graph to the left. So skewed left, what I want you to think about is that the graph is being pulled left even though most of the data is on the right, not the rights. There we go. All right, then we could have a symmetric distribution, which means that all the data is basically evened out. Okay, if you were to take this histogram and break it in half, that both sides should look very equal to each other. That is a good distribution. That's actually a good sampling of data. And then skewed right, kind of similar to skewed left, but skewed right means that the data is now being pulled to the right side, so we might have some outliers to the right, but kind of opposite again. Even though the data is being pulled to the right, a majority of our data is going to be found on the left-hand side. Okay, so we're going to look at, basically take a look at data, and our goal is to figure out what is the shape of the distribution, and then we're going to talk about why those things might occur and being able to read things. All right, now the last thing I want to mention from these is that you should also see this blue dashed line that's shown over each graph. Okay, when you have a nice symmetric distribution, this is what's known as a bell curve, because when it forms that shape, or when you look at the actual data overall, it forms the shape of the bell. I like to think of the old God Bless America, but the old Liberty Bell. Okay, think of a bell that looks like that. When you look at this distribution, especially if it's symmetric, it should look like a bell. So therefore, it's also called a bell curve. Just a little side note, a little information there for you. So let's take a look at our first example. What we have here is what's called a frequency table. So we're looking at the number of raffle tickets sold by students in your grade. So a frequency table, instead of looking at just data as in terms of one number, or two numbers, or three, whatever it may be, but we're looking at ranges now. So what we have here is we have a range of 1 to 8 tickets sold, 9 to 16, 7 to 24, 25 to 32. So it gives us a range of what tickets were sold. So when I say a frequency of 5, that means 5 students sold between 1 to 8 tickets. 9 students sold between 9 to 16. 20 students sold between 33 and 40 tickets. So it's giving me a frequency of how many students are actually selling a ticket, but now instead of just looking at one value, we're looking at a range. So what I want to do is I want to take this frequency table and I want to represent it on this histogram. Now, histogram, I want you to think of a bar graph, okay? So here's what you're going to have to do. You're going to have to put the tickets sold on the bottom of this graph. Sorry, my pen's not really working out too well here. And then what we're going to do is we're going to put the frequency over here, okay? So I'm going to basically take that column that we see here on the left side, and I'm going to write all these little ranges below. So I have 1 to 8, 9 to 16, 17 to 24, and 25 to 32. Keep going. I'm sorry about the sloppiness here. 33 to 40, 41 to 48, and then lastly 49 to 56. Sorry about the sloppiness there, and it kind of went into the graph. And then on the other side, I have my frequencies. Notice it ranges from 5, as is my lowest value, all the way up to 25. So here's what I'm going to do on the left-hand side. I'm going to go up 5, 10, 15, 20, 25. I'm going to go up by 5s, okay, all the way up to 25. And what you're going to do is that for each range of values we have here, we're going to plot a bar that shows our frequency. So from 1 to 8 tickets sold, I had about 5 students that sold that, okay? So I'm going to have a bar that goes up from 1 to 8 all the way up to 5. Next one, 9 to 16, I had 9, so that's going to go up to about a little bit below 10, okay? Then I have 17 to 24, so that's all the way up to 16, so that's going to be a little bit above 15. And then 25 to 32, we're all the way up to 25, so that's the very maximum value. 33 to 40 would be up to 20, so it'd be somewhere there. Okay, and then we have 8 and 7, so I'll finish up here. 8's going to be a little bit lower than 10, and then 7's going to be a little bit above 5. And if I'm a little off, I apologize. Okay, now based off of this, now we get the sense of where the data is located. And I want to know, what is the shape of this data? Is it skewed left? Is it symmetric? Is it skewed right? Here's what you can think about. Look at where about the middle of the data is. We see our largest value is right here around 15 to 32. So if I were to cut this in half, think about, we want it to be symmetric. Does it look about the same on both sides? Well, yeah, I have a value that's, relatively big on the left side and the right side. Then it gets smaller as it goes out. So the tail, what we looked at before, is going to be pretty symmetric on both sides. So if I were to draw that shape of that curve, okay, that curve is going to look pretty symmetric. So the shape of this data would be symmetric. Again, I apologize for that handwriting, but that's just the way it is. So that means this is a pretty symmetric data. That means all the data is pretty evenly spaced out. Okay, so that's just simply looking at the shape, being able to tell whether it's skewed one way or symmetric. Now, from this information, we're going to start to answer questions. All right, so for now, next one, we have a police officer measures the speeds in miles per hour of 30 motorists. The results are shown in the table below. So here we have a whole bunch of data. So what I want to do is, if I want to represent this on a histogram, what I am going to do is I'm going to make what's called a frequency table. Okay, so frequency table, what I'm going to do is I'm going to have, instead of looking at each individual value, I'm going to make a range of values. So what I'm going to try and find is my highest value and my lowest value. Okay, so my highest value, it seems to be, just looking at it, around 32. And then my highest value seems to be about 60. Okay? Now, I see a bunch of 60s in there, so here's what I'm going to do. Okay? I'm going to try and have a range that goes from about 32, so say about 30, all the way to 60. Okay? So here's what I would do, is I'm going to break this into 5-mile-per-hour increments. So I'm going to start, instead of starting at 30, I'm going to go 31 to 35 miles per hour. Then I'll go 36 to 40 miles per hour. 41 to 45 miles per hour. 46 to 50, 51 to 55, and lastly 56 to 60. Okay, so these right here, these values represent the speeds. I'm sorry it's overlapping there. And what I'm then going to do is I'm going to look at the frequency. Okay, so to find the frequency, I'm going to look at now how many speeds range in 31 to 35 miles per hour. Okay, I'll check these off in green so you can see. So I have, starting in the left column, I have 1, and then I go right column, got nothing left, and I have just one value, right? So that means my frequency here is 1. And now I'm going to go to 36 to 40. So 36, I'm going to start in the first column here. All right, so 36 to 40, again, I'm going to look here. Oopsie daisies, gotta get my laser tool here. All right, so what is going on, dang tootin'? There we go. All right, sorry about that, folks. 36 to 40, so I don't have in the first column, I have a 40 here, so there's a 40, they can check that one off. 36 to 40, I got a 38, that would fit in that range. And then lastly, I would have a 39 that fits. So right there, my frequency, I have 3. Okay? So again, I'm looking at those ranges and trying to find the frequency. So I want you to do next is I'm going to pause the video here, and I want you to find the frequency for these last 4 ranges. So go ahead and pause the video. I'll pop the answers up in just a second, but pause and try and find the rest of those frequencies. All right, so what you should find is you should have 5, 6, 11, and 4. So in total, we have 1, 3, 5, 6, 11, and 4. Now, what our goal is we're going to take this frequency table like the last example, and now we're going to plot it on the histogram. So I want you guys to do this one on your own. So why don't you go ahead and plot that data on your histogram. Again, down here on the bottom, I'll give you a little hint. On the bottom, you're going to have to put the speeds. And then on this column is where you're going to put the frequency, and then you're going to put bars for each one that you have. So go ahead, pause the video, and do that one on your own. All right, so hopefully you have something similar to what I have. Notice I kind of stacked the bar graphs right next to each other. Not the prettiest, again, drawn on a little iPad here, so it's not the best. But again, first of all, if we look at this, what is the distribution? What is the shape of this graph? Hopefully you are seeing that this one is, let me just choose a different color here, that this one's going to be skewed. Now don't get confused here, but it's going to be skewed left. Okay, again, a majority of our data, if you look here, 5, 6, 11, 4, that's kind of the big numbers of our data. Those are on the right side over here, and we have these 3 and 1, those lower numbers that are found on the left side. So this would be skewed left. It's going to be pulled left because of those values. Now, part B, which measures of center and variation best represent the data? So this goes back to the very first slide. We had 2 options. We have the mean and standard deviation, or we have the median and our box and whisker plots. So which one would be better? Now, because this data is skewed, what's that going to do? The skewed left means that our mean is going to be pulled to the left because of these lower values. So the mean is not going to be a good measurement of center here. So instead, the median is going to be something that is better. Okay? The median is going to be based off our data. What is our middle number? Where our middle number was, if we look at it here, would be somewhere between 5 and 6. Okay, so the median is going to be better, and because we see that it's skewed, our box and whisker plot analysis would be a better way to understand what is going on. So those are going to be the things. Median is our measure of center, and variation, that's our box and whisker plot. It's going to give us a better sense of what is going on because the data is being skewed. All right, now it says in part C, the speed limit is 45 miles per hour. So how would you interpret these results? So look at the ranges that we have here. Okay, 45 miles per hour. What you're given is these values here. Okay, so those are the ranges that we see a majority of the data. Well, think about that. 45 miles per hour is the speed limit. A majority of our data, 6, 11, and 4, are found at 46 to 60 miles per hour, and a lot less of our data is found here. I mean, you look here, there's not that many people. So if I were to interpret these results, look at the speeds and compare it to the speed limit, in this case, I would say that people like to speed. Right? They like to go over the speed limit. They don't like to drive under the speed limit, as we see here. Nobody likes to go below 45. There might be a few people, maybe you're old timers, I don't know, but majority of people like to travel faster than that speed. Okay, so from this distribution, we're able to make some assumptions on what is going on. All right, next example, we'll do this one a little quicker. So here you're given two histograms based off of text messaging between male students and female students. In this one, we are talking about our fancy emoticons, or what I like to call emojis, right? So those are the smiley faces. Yeah. So this is basically showing girls and guys who likes to use emojis in their text messages. All right, so it says compare the distributions using their shapes and appropriate measures of center. So let's start first. Top graph, we have the females. So the females, let's look at their distribution. Is it skewed left? Is it symmetric, or it's skewed right? So we are looking at the top values here. To me, if I look at it, we have kind of the middle area here where all the data is centralized, and it kind of looks like it's pretty even. It's a little skewed to the right. Or sorry, I shouldn't say skewed to the right. Sorry, bad vocab there. But I see that there's some higher values to the right, but to me, it looks pretty symmetric. All right, there might be a little bit of variation, but overall it looks pretty symmetric. Okay, for the males, you should see that a majority of their data is stacked to the left. Now, this is where it gets a little confusing. That means there are some random people over here that would use emojis a little bit more often, not as many males. So this one here is actually going to be skewed to the right. And now, I know that majority of the data is on the left, but we have those values on the right side that are actually taking the data and pulling it to the right. So that's why we're saying it's skewed to the right. So the next thing to understand is what would be better for us to analyze this data. So if we see that it's symmetric, okay, we have two options. We're either going to look at the mean and the standard deviation, or we're going to look at, because there's some variance, we're going to look at the median and our box and whisker plots. So since females' data are pretty much symmetric, we would use the mean and the standard deviation. I'll just put ST and then DEV, if that makes sense to you. We would use those that information to analyze the data. What that means, the mean again, is that the mean, if we look at somewhere around the middle, again, we could go ahead and calculate, but I would say the mean would be something between 30 to 39 females use at least 14 or so emojis in their text. Okay, because it's pretty centered, we use the mean, and then the standard deviation would tell us about within what range would we find a majority of those data. So when I look at it, looking at 20 to 40, so I'd say it'd have a standard deviation of about 10. Okay, mean of about maybe 30, and then from 20 to 40 would be our standard deviation. For the males, since it's skewed to the right, I would not want to look at the mean in this case, but I would look more so at the median. Okay, we see that a majority of males, 0 to 9 males, would use that many emojis that the females would use. So if we look at the median, we're going to get somewhere in the middle value, say somewhere around here. That means that majority of males probably use somewhere around 6 emojis within their text messages. And because we have it skewed, since we are looking at the median, we would take a look at our box and whisker plot, and that would tell us about where a majority of the males are actually using emojis. Okay, so since things are skewed, that would tell us we're going to use the median and box and whisker plots again. All right, in our last example here, we're going to do, instead of a histogram, we're going to go back to what we did in section 2, which is our box and whisker plot, again, to look at data. What we have here is a table that shows all the values that we've talked about up to this point. You can see we have the maximum minimum values, the survey size, which tells us how many people we surveyed, our quartiles, which again are our cutoff points where we split the data into fourths, our median, which is the middle value, our mean, and then our standard deviation, again, is how far we vary from the mean. All right, but now we're going to view this instead of from a histogram, but from a box and whisker plot. So what we're going to do is we're going to make a double box and whisker plot. What that simply means is we're going to make one for males and we're going to make one for females. All right, so I'll start with the males first. Again, for our box and whisker plots, we're going to want to plot our minimum and maximum. So that's found from the table. Our minimum will be 5, maximum will be 17. 2 and 17. So I would have a point at 2. I would have a point at 17. Those again represent the low and high point. Then our quartiles, I have my first quartile at 5, my third at 10. So I'll put a point at 5, third at 10, and then the last thing we need is the median, and the median is found at 7, so we'll put a point at 7. And then to draw our box and whisker plot, we're going to connect Q1 to Q3, draw a line down the middle for our mean, and then make our whiskers by connecting Q1 and Q3 to the high and low. All right? So I drew the one for the males. Why don't you pause the video right now? Why don't you draw the box and whisker plot for the female using the data shown in the table, and then we'll analyze it and answer questions B and C. So go ahead, pause the video, and do the box and whisker plot for the women. All right, so hopefully you have the green box and whisker plot on the top. So now we're going to answer questions B and C. So B says compare the number of pairs of shoes owned by men to the number of pairs of shoes owned by women. So we have a lot of things we can look at. I think the most obvious thing you can see is kind of the range of values. Male shoes, we range from 2 to 17 pairs of shoes, okay? So at most 17. Majority of our data, again, is in the box, so we see between 4 to 10. That's kind of our central area where a majority of 50% of the males would have shoes, so between 5 pairs to 10 pair. Women, we can look at the range here. They go from 4 all the way up to 24. And the box here, 50% of the women would have anywhere from 12 all the way to 17 pairs of shoes. So again, if you look at this, just looking at some of the ranges, so what I did here is just compare simply the range. I can see that based off of this, women obviously will own more shoes. Okay? Another thing I could look at is I can take a look at my data and I could look at the mean. I mean, the mean is the average. On average, males will own 8 pairs of shoes, females will 14. Now think of distribution and shapes that we've looked at. Okay, we just did some things with histograms. Also notice the box and whisker plots. If you notice how males, we are kind of skewed here to the right. Okay, see how we have this value all the way here. This whisker is a little bit longer. This area is a little bit closer. This one's a little more spread out. So that means here the males are skewed right, which means we might have a guy that owns a bunch of shoes. Maybe he has like 8 pairs of the same Jordans. Who knows? Okay, but he's got a lot of shoes. The women, their box and whisker plot's a little more symmetric. Okay, it's pretty evenly spaced out, which means that our women, the data for our women is pretty good comparable to the men. That everything's going to be centered pretty well, whereas the men's going to be skewed a little bit to the right because you got that one person that owns a lot of shoes. All right, so based off this information, we are going to try and figure out part C. It says about how many of the women surveyed would you expect to own between 10 and 18 pairs of shoes? Okay, so about how many women between 10 and 18. Now to figure this out, because we have an even symmetric distribution, what I'm going to take a look at for the women is the mean and the standard deviation because it's symmetric. So I know that the mean is 14 and the standard deviation is 4. So where are we getting this 10 to 18 pairs from? Well, 10 to 18 pairs, if you think of what the standard deviation means, that means I have 14's kind of in the middle, and I'm going to go plus 4 for my standard deviation to get me 18, and then the other way, I'm going to go minus 4 to give me 10. So that means a majority of the women would own between 10 to 18 pairs. So again, this is where the standard deviation comes into play. Now think about, here's where it comes into play as well. When we think about the histograms or those bell curves that I showed you, if I were to just sketch a bell curve, the mean, if you really think about it, where would the mean be on this bell curve? It's going to be somewhere in the middle. This would be our mean. Our standard deviation then would be plus or minus 4 based off of that. So I'm going to draw some lines here. So notice if I think about the standard deviation here, and that would be these values here, standard deviation, that's that little sigma symbol, okay, that what we're looking at is this region right here, okay, which is, if you think about it and look at the other two tails, is a majority of the graph compared to what we have here. What it ends up being, and this is something you'll just have to trust me on, is that the standard deviation, if you think of what we did, we really broke this graph into like thirds. The standard deviation represents about 68% of the data. So that means 68% of the women surveyed fall into this category of having anywhere from 10 to 18 shoes. So how do I figure out then the number of women? Well, if I know that there were 40 women surveyed, all I have to do is find 68% of 40. To do that, all I got to do is take 68%, convert it to a decimal, and multiply that by 40, and that would tell me about how many women own that range of shoes between 10 and 18 pairs. So if you punched it into a calculator, you should get somewhere around 27. So that means about 27 of the women surveyed own 10 to 18 pairs of shoes. Okay, that problem's a little bit sassy, but now we can start taking that standard deviation and actually fitting it into numbers, and now we can actually figure out some more media information based off of that. All right, so this is kind of bringing a lot of things together. There's going to be a lot of questions on what I've talked about here. So give the homework a shot, give those practice problems a whirl. If you have any questions, make sure you jot them down, and we'll talk about them next class. All right, folks, you did a great job. We'll catch you on the flip side. Peace. Big Dog's out of here.